Number 48 is from this block of problems as well. Number 48 says -5 times 3x minus 2 plus 5. I want to recall before I start this problem that we had one not unlike it, something like 3 times x minus 2. The focus is on the minus instead of the plus. When I did this problem, I multiplied the 3 times the x to get 3x, and then I chose to think of the minus 2 as plus -2. When I did that, it allowed me to use the addition symbol here and then multiply the 3 times the -2. In the next step, I simplified 3 times -2 to -6. And finally, just like up here, I said subtraction is addition of the opposite. Down here, I can say addition of the opposite is like subtraction. So I changed this to 3x minus 6. And then we said there's a shortcut here. We don't have to rewrite the problem from minus to plus the negative. We can jump straight from 3 times x to 3 times -2. We do still have to think of this as -2, but we can take a shortcut. In question number 48, this minus is like saying plus a negative. So I'm really adding -2. I can either think of that as plus -2, so that when I do my distribution, I end up multiplying -5 times -2, or I can skip that step and do it the way I did down here. I'm going to need to be careful though, because I'm multiplying -5 by -2. Let's try it by the shortcut first, but then I'll go back and make sure you understood what I did. So I'm going to distribute, but what I'm distributing is the number -5. -5 times 3x minus, if I use this shortcut, minus, now I've used that minus sign. I can't use it again. So now I need to multiply -5 times 2. -5 times 2. And then, of course, I can't forget that this plus 5 is a part of my question, so I need to add that onto that line as well. Using the associative property of multiplication here, I can reassociate the numbers, -5 times 3 times x, and then I'm going to subtract the number I get from this multiplication. -5 times 2 is -10. I still have plus 5 tacked on at the end. Finally, I can simplify -5 times 3 is -15 times x minus the opposite of 10, or -10 is positive 10, and then plus 5. Notice that here I have plus 10 and plus 5, so that's a total of plus 15. I can add those two things together. I can't combine anything else with the -15x because those are x's and these are not x's. This is my final answer. Let's go back and take a look at this problem again from a slightly different perspective. If I do in fact change this minus to addition of the opposite, then when I do my multiplication, when I do my distribution, I get -5 times 3x plus -5 times -2 plus 5. Reassociating here gives me negative 5 times 3 times x plus negative 5 times negative 2 is positive 10 plus 5. Negative 5 times 3 is negative 15 times x, and 10 plus 5 is 15. So I get the same answer, but the first time I did the shortcut where I just thought negative times negative, this negative here, was positive. And the second time I did it the long way, where I actually changed it to addition of the opposites. So this plus sign is what got brought down. You can do it either way, as long as you get the right answer. Actually, I've done this problem with way more steps than many of you may need to write down. You may be able to see directly from the original problem to negative 15x. Negative times a negative is a positive, so plus 10, and then plus 5, and finally negative 15x plus 15. And ultimately, that's what we would hope for you. But this course is about learning about these properties, so if this video seems too simple, well, that's great. Feel free to skip the intermediate steps. The thing is, when you're learning a new idea, the temptation is to skip steps or take shortcuts before you're ready. Don't cheat yourself. The only person who's going to see your work besides you is me. And actually, you want to try to impress me with how much you actually know, not with how many shortcuts you can take. On an exam, if you don't show your work, I can't give you partial credit. If you get the wrong answer, it's just wrong. If you've shown me your work, if you've shown me the thought process behind what you're doing, there may be room for points, even if it's not all of the points. So taking shortcuts is fine if you're absolutely confident that you're right, but don't take them before you're ready. Either way, I'm going to ask you to show me some work on an exam. For example, this would constitute showing your work, almost to the extreme, but that's fine. This would receive full credit. This version would also receive full credit, not just because it's right, but because you've shown me how you got 15x. You've shown me by using arrows that you're distributing, for example. And you've shown me that you remembered to add the 10 and the 5 at the end. So this would also receive full credit. Let's take a quick look at something that would not receive any credit, even though it's correct. Obviously, when you take your online exams, Exam 1 and Exam 3, WOMAP's not going to care whether you show your work or not. But on the midterm and the final exams, I do care. I'm going to insist that you show me some work. If this is the problem, and you write down this answer, even though it's correct, you will receive no points. I need to know that you didn't just glance at your neighbor's exam, or perhaps coincidentally have this example written down on your note card. I need to know that you know how to do the algebra. So even though this question has the correct answer, because there's no work at all shown, no arrows, there's nothing here. This answer is correct, but it would receive no credit. Okay, we still have a couple more examples to do, so let's get on with that. Question number 60. Question number 60 comes from the same block of problems, the Part B questions. Negative 3/5 times 15x plus 5. The distributive property takes the number in front and multiplies it by each of the terms inside. So, negative 3/5 times 15x plus negative 3/5 times 5. Now, I need to reassociate these, so negative 3/5 times 15 times x plus a negative times a positive is a negative. And I can think of 5 as 5 over 1. And if I multiply straight across here, I get 3 times 5 is 15 over 5 times 1 is 5. Here, I get a negative times a positive is a negative. And 3 times 15 is 45 over 5 times 1 is 5 times x. Addition of the opposite can be written as subtraction. So I get minus 15 over 5. And finally, 45 divided by 5 is 9. And 15 divided by 5 is 3. So this is my final answer. Let's back up a couple of steps and take a different look at the multiplication with fractions. I still need to reassociate these numbers, so I'm going to have negative 3/5 times 15 times x and negative 3/5 times 5. Here, a negative times a positive is going to be negative. And here, addition of the opposite is the same as subtraction. I'll bring that x down. Now I have to figure out what number goes here and what number goes here. I've already done the negative times positive part, and the addition of the opposite is subtraction here. So I'm just looking for a number and a number. In an earlier video, I talked about thinking of 3/5 times 15 as 3/5 of 15. When I do mental math like this, what I do is I think about what is 1/5 of 15. 1/5 of 15 is 3. If 1/5 of 15 is 3, then 3/5 of 15 would be 3 times that, or 9. 1/5 of 5 is 1, and 3 times that is 3. If you'll remember a minute ago, that's the final answer I got. It was up here in that version of the problem. So that's just a little mental trick that I sometimes use when I'm multiplying with fractions. Question number 64. Eight times 1/4 x plus 5/8. Distribution gives me 8 times 1/4 x plus 8 times 5/8. Reassociating these numbers gives me 8 times 1/4 times x plus, this is going to be 8 times 5/8. If I use the same trick in this question, 8 of 1/4 doesn't make sense. But the commutative property of multiplication lets me rewrite this as 1/4 times 8 times x and 5/8 times 8. 1/4 times 8 means 1/4 of 8. What's 1/4 of 8? It's 2. 5/8 times 8 means 5/8 of 8. Well, what's 1/8 of 8? 1/8 of 8 is 1. So 5/8 of 8 must be 5 times 1, or 5. Now, of course, you don't have to do it this way. That's just a mental trick I use when I'm multiplying with fractions. Of course, you can write 8 as 8 over 1. And in fact, you could have done that back here. And then think 8 times 1 is 8 over 1 times 4 is 4 times x plus 8 times 5 is 40 over 1 times 8 is 8. But of course, 8 over 4, 8 divided by 4 is 2. And 40 divided by 8 is 5. So you still get the same answer.